Hey there, it's Miss B, and in this video, we're looking at the Unit 2, Lesson 2, Cumulative Practice Problems, and this is Illustrative Math Geometry. So, this is all about congruent parts. So, first off, we have line SD as a line of symmetry for figure AXPDZHMS. Noah says that AXPDS is congruent to HMZDS because AX and HM are corresponding. Why is Noah's congruence statement incorrect? And write a correct one for the pentagons. Okay, well, first off, they named a bunch of things here, so I'm just going to color over their line of symmetry here. That's this red line SD down the middle. And then I'm going to highlight our two different pieces that they're talking about. AXPDS looks like this shape here, and HMZDS looks like he's talking about this shape here. Okay, so let's actually dive into why he's incorrect. And pretty much it's going to be because order matters. Let's actually follow AXPDS around the outside. So AXPDS. So we're kind of starting at the outer corner, following the little W shape and ending up at S. If we follow HMZDS, HM goes up, and then we come down to Z, and then D, and then S. So we're not following the same pattern, but he says AX and HM are corresponding. So we're going to have to rewrite Noah's statement. So this congruent statement is incorrect because the order should tell us which parts correspond. And so he's starting with A, and then he's starting with H, and A is our top corner and H is our bottom corner. So these parts do not correspond. A should be corresponding with M instead. So I'm going to say, and angle A does not correspond to angle M, or I'm sorry, angle H. You can say his order is wrong. Okay, so if we want to write the correct congruent statements, we can still stay with AXPDS. That is going to be congruent to MHZDS. Not HM. That's the only difference, but it's an important one. Okay, looking at question 2, we have a figure MBJKGH. So that is, let's just label this as we go through. That one's going to be blue, so that is MBJKGH. This one right here. It's the figure of AFEKJB after being rotated 90 degrees counterclockwise about point K. Okay, so that's the image of this green one right here. And we're rotating it around point K. I'm just going to make that obvious for myself. So point K is right here. Okay, draw a segment in AFEKJB to create a quadrilateral. then we're going to draw the image of the segment when rotated 90 degrees. So we're just going to draw ourselves a segment and then draw another segment, and then write a congruent statement for the quadrilateral that we created in each. So you can ultimately select any points here to kind of connect. Well, not any points, but there are a couple different answers for this. So if I am going to, let's see, what was our, the blue one was first, and actually I didn't even highlight this as the image. I know I did that reverse of the other one, but the blue is the first, the pre-image, and the green is the image. So let's create our line maybe between J and H, just cutting off the corner here. I know I'm not making like a nice rectangle, but JH is probably the best choice here. Actually, I think that's the only major choice you can make. I know I said you can do a couple things, but this is the only one that's really obvious to me. So if we make that same line, it's going to be from E to B. So we can say write a congruence statement. That is going to be, let's say, which chunk do we want to use? Because technically we made two quadrilaterals. Let's say BJHM. So I will say BJHM is congruent to, and that would be B corresponding with F, that would be FEBA. So BJHM would make this quadrilateral here, and then our rotation of it would be FEBA right there. And that's it for number 2. Looking at question 3, we have triangle HEF as the image of triangle FGH after a 180-degree rotation around point K. So now we want to select all solutions or all statements that must be true. So we want ones that must be true, not ones that seem true, ones that have to be true. So this was actually part of one of our exercises in class, and we knew, or we proved, that this created a parallelogram when we had a triangle and we rotated it around 180 degrees around the midpoint of the base side right there. Okay, so FGH congruent to FEH. Let's actually just trace those out. So this says FGH congruent to FEH. That would be true if this was a reflection across this middle line, but it's not. So not one of our answers. EFH congruent to GFH. That's saying basically the same thing. EFH congruent to GFH. Again, true if it was a reflection, but it's a rotation. KHE is congruent to angle KFG. KFE, or I'm sorry, KHE congruent to angle KFG. That is true. I would have these angles right here. Those are going to be alternate interior angles. So we have that. GHK congruent to KHE. GHK, KHE. They are again GHK and KHE. They're giving us these angles that are right next to each other right here, and those aren't necessarily going to be congruent. Segment EH is congruent to segment FG. So we have EH and FG, and that is true. We're going to have the opposite sides congruent. Segment GH is congruent to segment EF. So segment GH congruent to segment EF, that is also true. So your correct answers are C, E, and F on this question. Moving along to question 4. We have when triangle ABC is reflected across line AB, the image is ABD. Why are segment AD and AC congruent? Okay, so they're already telling us we're reflecting it across this line right here. They want to know why is this side and this side congruent to each other. So let's look at our reasons. We have congruent parts of congruent figures are corresponding. We have corresponding parts of congruent figures are congruent. An isosceles triangle has a pair of congruent sides, and segment AB is a perpendicular bisector of segment DC. So, this one here is all about corresponding parts. So, while yes, A seems correct because it is basically saying CPC FC, B is the actual correct order of the words. Because if they correspond in congruent figures, then they are congruent. So the corresponding part does need to come first. So our correct answer is B. Corresponding parts of congruent figures are congruent. So CPC FC. But the correct version of CPC FC. They try to throw you off with question or option A there. Okay, number 5. Elena needs to prove the angles BED and BCA are congruent. Provide reasons to support each of her statements. So first off, we have that line M is parallel to line L, and we have angles BED and BCA are congruent. So we're going to supply reasons, because obviously the second one here is the statement that she's trying to prove, that BED and BCA are congruent. So why is she able to say that line M is parallel to line L? Well, it looks like, if we zoom in on our picture here, we were given that we have two angles being marked as congruent. And these angles are corresponding. So the inverse of the corresponding angles theorem says that if we have two lines cut by a transversal, so two lines cut by the transversal, in this case we're going to say it's BA, and corresponding angles are congruent, then the lines are parallel. The original version says that if the lines are parallel and cut by the transversal, then we have the angles congruent. But so we're using the converse here. So we can say this is converse of corresponding angles. And then I'm actually going to provide some detail. So I like to name the property or the theorem, but in this case, they're not just having us write a proof where I'm supposed to state that. I actually want to give some more detail here. So we're going to say angle BDE corresponds with angle, and this is BAC, and they are congruent. So line L parallel to line M. That's the more detailed version of it, but using that property. Okay, so now for BED and BCA, that is this angle here and this angle here. We want to know why we're allowed to say those two red angles are congruent. And that is because now that we have proved that our lines are parallel, we now actually have another pair of corresponding angles. So we're going to say angles BED and BCA. Say they are corresponding angles. And then we'll add a little bit more detail. We're going to say they're formed by parallel lines L and M and transversal BC. So just specifying like what the actual transversal is there that's created. Okay. Moving on to question 6. So triangle FGH is the image of isosceles triangle FEH across line HF. We want to select all statements that are a result of corresponding parts of congruent triangles being congruent. So not necessarily all things that are true, but that are a result of CPC-FC, or in this case, CPC-TC. So we always want to be careful with what we're actually looking at here. So if I know that I have corresponding parts congruent, and did they say this was a reflection? Yes, they said it was a reflection across this middle line. So I'm going to just mark all of the pieces that I know should be congruent. In which case, that is going to be these lines here. And since both of them are congruent at the top with a single congruence mark, we can put both of them congruent at the bottom here the same way. We know that this angle should be congruent to this one. We should have this angle congruent to this one. And likewise, actually, we haven't really quite proven it yet, but we're going to have these angles be that same size. And then we can even say that this mark in the middle, it's going to be congruent to itself. So that's pretty much as I can draw on here. So now let's actually find all of our stuff. So EFGH is a rectangle. Well, there is actually nothing that shows me these have to be right angles, so we're not going to use that one. EFGH is a rhombus. That part is true because a rhombus has 4 congruent sides. And this does have 4 congruent sides. Okay. Option C says diagonal FH bisects angles EFG and EHG. So that is saying that it bisects my 2 corner angles on the left here and the right, or the right and the left in the way that I drew them. And that is true because if we know one angle is congruent, we know the other is because it's a reflection. So if these are cut into 2 equal parts, that means it's bisected. So that bisection part is going to be true. So we would say, yes, C is correct as well. D says diagonal FH is perpendicular to FE. There's nothing that actually tells us those 2 pieces need to be perpendicular, so nope. Angle EHF, so EHF is congruent to angle FGH. While that may be true in this case, we don't necessarily know that because of corresponding, because those don't correspond with each other. These two angles do, and these two angles do. So that's not true by CPCTC. Angle FEH is congruent to angle FGH. So FEH and FGH, yep, that's the top and the bottom angles here. So that is by CPCTC. So we have B, C, and F as the correct responses for question 6. I think we have one more question. Oh, no, we do not. That is where we're ending this lesson. So thank you for joining me. This was Unit 2, Lesson 2, the cumulative practice problems for illustrative math geometry.